I've had the privilege over the years to work with every single grade kindergarten through doctoral student, but my 4th through 8th grade coding classes were a lot of fun to facilitate because kids could code music using Ruby and Sonic Pi, create art and animation with JavaScript and Khan Academy, create apps for iPads and iPhones using Swift, Swift Playgrounds, and Xcode, or create a variety of projects in Scratch. This was fun for the kids because they had options to pick from, but it was also fun for me because I was facilitating multiple programming languages in the same class. Today's podcast uses slides from my CSTA presentation this summer to talk about how I facilitated multiple programming languages in one space. Because I saw hundreds of kids who were required to attend my classes, I asked questions like, how do we differentiate for students who are required to attend and aren't interested in computer science, or are already pursuing a career path outside of computer science, or have a wide range of computer science experience? I literally had some students who had never seen a computer before, and others who regularly go home and program. That was quite the range of experiences. But what about students who have varying access to devices or internet at home, or have various accessibility needs and accommodations, or have variegated identities and interests, or just want to impact the world in ways that we haven't considered? Instead of using a sequential design where everyone went at the same pace through the same project sequence, my solution to these questions was to use a rhizomatic design where students could start with or create whatever project sounded interesting to them, and they could then move on to any other project that interested them on any one of the languages and platforms available to them. I provided a variety of project options, from fixed projects where students create projects with similar results, to more open-ended projects where students created something with results I couldn't predict. I did this not only through a variety of project types, but the option to code with blocks in Scratch, Ruby and Sonic Pi, JavaScript in Khan Academy, or Swift in both Swift Playgrounds and Xcode. Now, I'm going to play a video that I made for the school board presentation back when I was still teaching in the classroom. In this video, I asked students to just share, why do you like coding? And in the video, if you actually watch this on YouTube, you'll actually be able to see some projects that students created, and there's quite a variety of them. So let's take a listen to this, or watch if you're watching this on YouTube.
We create a lot of things with technology at Desert Thunder. With Scratch, we make video games, stories, and more.
I like coding because I have the ability to make my own games and do anything, and it's pretty much limitless. And I can also choose, like, if I want to change something that I don't exactly like in another person's game, I can get the opportunity to change it without actually changing their original game.
I think coding is a good way to express your feelings, and it's a better way to learn. It's better than using textbooks.
So far we've had like a race car project. We had a project where a student created a simulation of a computer, and it was an old computer intentionally. And so it had viruses, and you can like download an antivirus, and it had games, all sorts of fun stuff like that.
I like coding because I get to like code games and like help people with their own coding. Cause
now I got a Pokemon game.
They might need help, or just might need to like
Snake multiplayer.
That happened.
I like coding because you get to create games that you like to do.
Character
I like
creation.
coding because when you grow up,
Project about
you
themselves.
can make games, and you can be a game maker. And well, yeah, you could be a game maker. You can make some money, and you can make apps for everyone to play.
I like coding because you can
little
do
story.
whatever you want.
These
and
are all in
there's
Scratch.
No limit to your imagination.
We use JavaScript to create art and animation.
I like how technology is something that you can express what you want on a computer, and how you can make any video game you want, or any type of coloring you want, or like drawing. And I like how, that's just like, I think it's kind of cool that we can do that.
Now we've got a bunch of different projects in JavaScript. So in JavaScript, you can create art and animation and whatnot. So we've seen like a bunny rabbit. We've seen like their favorite soccer or football team logos, and like an animated bus stopping at a bus stop. Like there's a lot of really interesting stuff that like I wouldn't have thought of. Like, hey, student, would you be interested in making a bus and animating it and stopping it at a bus stop? So it's really interesting to see what these students were able to come up with.
We get to do a lot of coding and do drawings and a lot of
Goodyear blimp flying over a house.
Like, let's say making a monkey dance and twirl around.
I like coding because I learn new things.
I like coding because it's easy and fun. I like coding because it gives you the opportunity to make your ideas come into an actual thing that people can do and use.
I like coding because you can be creative. I love coding because you get to make your own games and you get to make your own music.
We even use Ruby to make music with Sonic Pi. In fact, all the music you've heard in this video has been created through code by kids at Desert Thunder.
I like
So all the background songs that you were listening to were created by kids with code. And so on the screen, if you're watching this, is a bunch of code on the left-hand side that students wrote out. And on the right-hand side, you can see what is being played at that moment on it. So Ruby, you're able to create all kinds of stuff in Sonic Pi using very syntax-light language to be able to code live music or composed music.
Coding because we're able to make music and do other projects that other people do and remix them.
I like coding because you can actually make money off of it. You can grow up to be a great magician.
He meant musician.
And you can actually make music for yourself one day.
I like coding because you can make music on Sonic Pi and because you can remix other people's projects and make them better.
Kids also have the opportunity to engage in professional app development with Swift. They have a lot of apps that they can choose from, and I've created some guides that show you how to create an app from the very beginning. It starts off with showing you how to create your own interface, where you drag and drop your buttons, images, labels, things that you're...
So it's now showing some of the tutorials that I created. And this was before I became like a full-time curriculum developer. I was just making this stuff for my classes. And they are available on my website. They are probably very much so out of date in terms of like not up to the latest language of Swift. I was using Swift 3 at the time. It's probably on like Swift 10 by now. But if you're interested in it, you can find it at jaredoleary.com/Swift.
You're going to use to make the interface look good and usable. Next, it actually walks you through how to code all those buttons and things that you've put into your interface. It shows you descriptions and goes step by step on how to actually create the code. By the time kids get all the way through it, they've coded a lot to create their app, and they can actually use it on their iDevices and put it on the App Store. The Media Arts and Technology Makerspace is...
Now we had a middle school elective, and this class had a wait list where students, there was like way more who wanted to attend than would sign up. Some students would even put on like the elective sign up. The only thing they put was the Media Arts and Technology Makerspace. And they'd say, this is the only class I want. Do not put me in anything else. So it was a very popular class because students were able to do all this coding stuff and then everything else that you're going to hear or see in this video.
Is a middle school elective with a lot of project options available. Kids often will create pixel art of their favorite video game characters or short animations. Some will create stop-motion movies or short films, and then others will create music and more.
I like stop motion because I can like make my own movies, and stuff, and I have a lot of stuff in my mind.
Now, I'm pausing it again. So some of the pictures that you might not be able to see, like students are creating Play-Doh drum kits and they're attaching it to a Makey Makey so they can play with that. Or there's a student who's holding up a method book for their band class and they're taking what they were learning in their band class and writing it out in Ruby in code and basically transcribing it into there. Some students also did that in Scratch as well. So it's really interesting to see how all the intersections that students were creating with like some of the other classes, bringing that material into here and finding a way to recreate it with code.
This class because we get to make the projects our own.
It's a great way to learn, and it's more modernized since like it's more an interactive way for kids to learn other than just reading it out of a textbook, because you're actually like interacting with it more and you feel like better about school and you're not bored.
It's good for like kids of all ages. They could
like so
start
honest.
a career out of it if they get like really good in the high levels. They could have like make a job.
Coding is fun, but sometimes hard. It makes you focus more.
Hi, I'm William. I like to code because you can make your own stuff, and every time you code, it's basically like a new experience. And every time you code, it's basically you're the master of your world. Bye.
This is just
I love how he ends with bye. So if you want to see that full video without me interrupting it, I'll include a link to that in the show notes. The video is exactly 5 minutes long, so it's pretty short. Now, just to be clear, everything that you just heard or saw in that video was not something that I started with on day one of my teaching, especially since I don't have a background in computer science. I started with one language and platform and gradually expanded to new languages and platforms each semester. And this is the approach that I'd highly recommend if you're interested in considering doing something similar if you want to facilitate multiple programming languages in one shared space. Look at the long term and figure out what you'd like your kids in your class to be able to do or create a year or two from now, and then figure out what you would need to know and be able to do to be able to facilitate that kind of experience. Or even what kind of resources you might need to create, like some of the step-by-step guides that I created for Swift. because everything else that I was finding was geared towards adults rather than something that a middle schooler or even had some fourth graders go through those tutorials. Now let's talk about some tips for selecting a language or platform. When I was determining a new language or platform to introduce into a classroom, I'd ask myself questions like, does this new language or platform afford new creative or expressive opportunities? For example, kids felt constrained by the music options in Scratch, which is something that I talk about in other podcast episodes on the intersections of music and computer science. So I introduced Sonic Pi, which allows people to live code or compose music with the language Ruby. Even though all of my degrees are in music education, the language and platform was chosen in this scenario because students expressed an interest in expanding their music making abilities with code, not because I was interested in it. Another question is to consider, how well do you currently know the language or platform, and how quickly could you learn it? If the syntax is similar to another language, then it might not take a lot of time or effort to add it to the list of options. However, you also need to consider the layers of support built into the platform you're using. For example, will the platform be self-guided like code.org or Khan Academy? Or will it require you to create resources or provide more one-on-one support like I had to do with Swift? If you have the time to create resources, great. If you don't, perhaps select from options that have a robust set of student-facing materials that are age appropriate, because that will make it much easier for you to facilitate. Another thing to consider are the entry points. Are students always creating from a blank slate, or are there opportunities to remix existing projects or build off of half-completed projects? So for example, is the platform easy enough for a beginner? In other words, does it have low floors? Is it complex enough for advanced students? So does it have high ceilings? And does it have the opportunity to create a variety of projects? So does it have wide walls? Check out the interview with Mitch Resnick if you want to learn more about the concepts of low floors, high ceilings, and wide walls, which I'll link to in the show notes. Now let's talk about some implementation suggestions. So once you have more than one option, I'd recommend starting each semester spending at least one entire class period exploring the kinds of projects that a student might create in one language before moving on to the next language in the following class. After cycling through each of the available options, give students the opportunity to choose their own path moving forward. However, one of the things that I felt was important to let students know is that they had the opportunity to switch languages or platforms or projects whenever they wanted to. So they weren't stuck with the decision that they were ultimately unhappy with. There have been so many projects in my own leisure and whatnot that I thought would be interesting that I ultimately sat aside in favor of something else. I personally don't see a problem with students moving on to something that better piques their interest, as long as they're not just giving up midway through because something is difficult. Because students were also coming up with their own projects or were selecting from some starter projects and prompts that I created, deadlines were completely flexible. Some students worked on a project for a couple of days, while others literally spent multiple years adding onto their game. My admin was okay with focusing on process rather than product, so that worked out really well for me. To support just-in-time learning, I used the following process that I displayed on the board for every single class. It's called the If You Need Help list. Step 1 was to check the built-in help or resources, also known as RTFM, which the family-friendly version would be read the free manual. Step 2 was to ask a friend for help. Step 3 was to ask another friend for help. And then step 4, if I'm not working with somebody, is to ask me. Otherwise, the students were supposed to repeat steps 1 through 3. This approach encouraged peer-to-peer learning, and I would often answer a student's question by helping them find another student who I knew could answer that. So if Johnny came up and was like, hey, I need help with player controls, I'd be like, great, Susie is fantastic at player controls, go talk to Susie about that. If you want to learn more about peer-to-peer learning through a simple assessment process, check out episode 193 of the CSK8 podcast, which is titled Critical Response Process. Now, I was able to implement this support system and spend the majority of my time working one-on-one with students because my classroom was set up like a racetrack with 2 rows facing the outside walls and 2 rows facing the inside of the room. This allowed myself and kids to walk around the room and relatively easily see about 75% of the screens at any moment as I walked around the room. The setup was much easier for peer-to-peer collaboration than rows facing the front, which limit the ability for students to move around or for you to see all of the screens unless you're standing at the very back of the room. Another option that you might actually do is to have pods or columns facing inward to encourage dialogue, for example, creating pods of students working on the same platform or language. But my favorite room setup was a donut, where all of the tables faced the walls on the outside of the room, and the center of the room had tables for unplugged and collaborative work. This approach not only allows you to easily monitor all of the computers but it makes it easy for students to get up and ask for help. If you want to learn more about these setups, check out episode 195, which is titled How to Set Up Your Computer Lab, and I elaborate on those concepts in that particular episode. Now, while I was walking around the room, I asked a variety of questions. So I'm going to skim through some questions that are on the slides kind of very quickly because you can check them out in your own leisure and listen to the podcast episodes linked in the show notes that talk about it. But there are some starter questions, questions for stimulating computational thinking, some assessment questions, some discussion questions. There's also questions around different levels of thinking like memory, translation, interpretation, application, analysis, synthesis, and evaluation, as well as some different types of question types like open, guided, and closed, analytical, judicial, and creative, etc. But if you want to hear more about these different question techniques that I just very quickly went over, that I was using frequently while I was facilitating multiple languages in one shared space, check out some of the podcast episodes in the show notes. But as a very quick summary of like the approaches that I'd use, I would often pose guiding questions to a student and then walk away to go and help another student. And then I'd circle back to that first student after a few minutes just to check in on their progress. If a student asked a question that I knew someone else struggled with previously, again, I'd kind of pair them up with them to kind of encourage that peer-to-peer learning with each other. Another thing worth noting is that when I was first learning a language or a platform, I'd tell students when I didn't know an answer to a question. I'd write their question down, and then I'd come back the next day and explain not only the answer to their question, but also how I found an answer to their question. So that way they can learn how to teach themselves in the future. Now, in general, you could describe this approach as facilitating multiple languages and platforms in one space through one-on-one coaching and peer support. It required a lot of prep work on my end in terms of learning the languages, platforms, curating and creating step-by-step guides, developing classroom norms for peer support, etc., etc. However, the actual facilitation side of things was relatively easy because I spent the majority of my day helping kids problem solve their bugs by asking guiding questions without actually giving them direct answers to the questions, usually speaking. This approach was very different than what most admins were looking for in a classroom, so I created a crosswalk document that actually translates the TAP teacher evaluation system that my district used into language that made sense for this approach to computer science education. And we would give this document to admin who were unsure how to evaluate what computer science educators were doing in the district. I'll include a link to this in the show notes, but it's a fairly lengthy document because it goes through every single step on the rubric of how teachers were being evaluated in the classroom, and it translates it to what it would look like in a computer science class that allowed you to facilitate multiple languages in one shared space. This approach to teaching multiple languages simultaneously was based off of a philosophy of learning called rhizomatic learning, and this can be applied to a single language or platform or in multiple. Again, in the show notes, I'll include links to some podcast episodes that talk about this. Now, if this approach is too overwhelming for you right now because you are new to computer science or computer science education, I highly recommend checking out episode 192, which is titled How to Get Started with CS Education. Professional development is great. However, most professional development does not give you the depth that you can find in the resources that I provide in that particular episode. I say this with confidence because I have developed over 50 hours of professional development and almost 3 times that amount in podcast interviews and episodes where I unpack scholarship in relation to computer science education, or these professional development sessions where I kind of like walk you through how to do something like set up your computer lab or whatever. So check out episode 192 if you're interested in finding some more resources that will guide you through different phases or stages of being a computer science educator. After a couple of semesters of teaching computer science with one language or platform, you might be able to start embarking on a rhizomatic journey to get to the point where you can start teaching multiple programming languages in the same space at the same time. Now, for those of you who have been listening for a while, you'll notice that I stopped doing the weekly podcast episodes, and the reason why is because I am now cycling through creating a podcast episode, a Scratch tutorial, and a drumming tutorial. So I'll have a new podcast episode coming out roughly every 3 weeks or so. I'm just trying to make sure that I don't get burned out with all of the computer science, gaming, and drumming content that I create, which I'm having a lot of fun with, but it takes a lot of time to create all the content that I make. So I've got literally thousands of videos on my YouTube channel. So stay tuned for plenty more content, and if you enjoy this stuff that I create, just consider sharing it with other people, as it helps more people find it. Stay tuned for a future episode. Until then, I hope you're all staying safe and are having a wonderful week.